Hi guys. A friend contacted me with this one, asking me if I'd heard of these things. I hadn't, and this is not my area of expertise. However, I will say that I do tend to focus on disaster documentaries such as boat or ship disasters. I've even done a few videos on them. In fact, I have one video waiting in the wings to be uploaded on ship disasters. So one would think that I would have come across this at some point, wouldn't one? Warning, if you're eating, I suggest you stop and heat up your food later, much later. I also want to announce that I added club membership to my channel here. It doesn't change anything as far as you guys are concerned. However, should anyone wish to support my work on YouTube, you can now do so by becoming a member. I pledge to start providing more updates and early releases to those members once I reach the first milestone of 5 members. I have set only one tier at $4.99 as I don't really want to make this channel too complicated. I earn a little money on monetization with videos that don't get copyright claims, yeah? Not all of my videos make it through, and I would rather publish a quality video than go back and replace the copyright claimed parts with generic images that may or may not fit what I'm saying. So I tend to lose a lot of monetization as I'm going along. I upload it and I get a copyright claim and I just let it run. There is also my Patreon, which is more for my general creativity. So my music, web design, tutorials, true crime videos, etc. I believe the channel membership is a monthly payment. So if you want to show your appreciation but don't want to commit yourself to a monthly payment, you can always use the thanks button just below each video. This is a one-off payment of your choice. It's like a tip. With all that stuff said, let's continue putting any food aside that we have and get back to shipworms. When you see headlines like "Incredible rock-eating shipworm is first of its kind," you know you're looking at a probable ME. Either that, or they have cloned a new species without knowing about it. Problem is though, scientists are continuously baffled. I wonder why. So what exactly are shipworms? Firstly, they're not worms, as the name suggests, although it's easy to see why early naturalists classified these as worms. They are actually bivalve mollusks belonging to a group of saltwater clams that have long, soft, naked bodies and are notorious for boring into and eventually destroying any wood that is immersed in seawater, including structures such as wooden piers, docks, and ships. Sometimes called termites of the sea, it is only recently that they are beginning to understand how these burrowing clams work. And this is the focus of the ME in this video. I've never heard of shipworms, although I had indirectly known of the damage they can do, but certainly not to the extent of what we see in this video. There are approximately 65 species of marine bivalve mollusks. The most notorious of them is the Teredo navalis, also known simply as Teredo, originally believed to be native to the Caribbean Sea. They possess ropey, translucent bodies that, depending on species and environment, may grow longer than a meter. Specimens of a full 60 centimeters in length and 1 to 2 centimeters in diameter have been observed in Danish waters. The lifespan of a shipworm is 2 to 3 years, and it lives all its adult life inside wood at depths where it is available. It can therefore be found from the surface down to significant depths. And the male has a lot of work to do, or a lot of fun, depending on your perspective, because there is 1 Teredo male per every 1,500 females. And the fighting that goes on between them is amazing. After fertilizing the eggs by the male Teredo, the developing eggs are protected inside the female until they develop into free-swimming larvae. Then, the little terrors meander in the high saline sea until they find fresh wood to settle on, unless they get eaten first by something else. And by the way, they don't like old wood. This will also be important a little later in the video. Then it starts burrowing through the wood as it grows, funneling the shavings into their mouths, turning wood into both a protective shell and a meal. They burrow parallel to the grain after drilling into the surface of submerged wood using valves on top of their heads akin to tiny helmets, as well as rows of tooth-like protrusions, only turning to avoid any knot on the wood or if there is any obstruction. By the way, fun fact, there are some shipworms that do not actually turn as they're burrowing through when they cross paths with another shipworm. They will actually bore through the other shipworm. I told you should have stopped eating. By the time it reaches adulthood, it is already at least a foot long and half an inch thick, creating burrows that can become several centimeters wide. Unlike other typical clams, the shell covers only a tiny portion of the teredo and is used more like a drill bit to burrow a circular hole through the wood. The tube-like home is capped at the opening of the burrow with a secreted calcareous cover with protruding siphons that allow the animal to breathe, feed on plankton and excrete wastes. Inside its burrow, the teredo's colour is pinkish white. If the animal is alarmed, it withdraws the siphons and protectively blocks the opening of the tunnel. If one does manage to remove a teredo from its home, its colour changes to a lighter blue shade in just a few minutes. The shells have openings that allow each worm to stick its foot out of one end and the rest of its body out of the other. Using its foot like a suction cup on the wood, the worm then proceeds to rock the two halves of its shell back and forth in a kind of scissor motion, scraping away at the wood and grinding it down into edible particles. They spend a lot of energy chewing. Digesting wood's complex structure isn't easy, explains Dan Distel, a research professor at Boston's Northeastern University. So shipworms essentially farm bacteria inside their gill cells, which in turn furnish wood-busting enzymes. This is a statement from one article, and it gives the impression that they understand how these organisms eat wood, which contradicts other articles and statements. Digestion usually has to do with microbes, but shipworms, which are actually saltwater clams, have only recently been found to possess surprisingly sterile guts, according to new research from scientists at UMass Amherst. While their gills can send enzymes to digest cellulose when needed, researchers can't figure out how the bivalves work through lignin, which is the concrete in which the sugars of wood are embedded. Unlike wood-devouring animals on land, such as termites and earthworms, shipworms don't seem to tackle lignin in the same way. They're missing the enzymes that usually break down this tough material. I combed through the entire genomes of 5 different species of shipworm, looking for specific protein groups which create the enzymes that we know are capable of digesting lignin, says microbiologist Stefanos Straforavdis from the University of Massachusetts, Amherst. My search turned up nothing. So how are shipworms digesting all that wood? It remains a mystery. There are other organisms that tackle this problem without enzymes, for example the gribble worm. This is another wood-boring marine crustacean that doesn't use enzymes to break down the lignin in its meals. Instead, the gribbling worm secretes hermocyanins in its gut, which are proteins that can make lignin more porous, allowing other enzymes to penetrate and break down the cellulose inside. Some fungi also use a non-enzymatic strategy when gobbling up wood. The brown rot fungi, for instance, supplements a small suite of gut enzymes with an array of reactive oxygen species, which can break down lignin even faster than enzymes. Perhaps shipworms do something similar. We just don't have enough research to say. And that is also a point of this video. Okay, why don't they have enough research at this point? The inside of the burrows it digs in the wood is clad with a thin lime layer, and this remains even after the animal itself is dead. The lime layer provides protection against the environment, just like a shell, and the passage is sealed at the end with a plug called the septum. In the plug, there is a small hole where the shell siphon can be inserted to breathe in fresh water. The siphons can be quickly withdrawn in case of danger and are protected under a pair of 0.5 centimeter long lime-like tentacles. The tunneling behavior of the shipworm inspired Marc Brunel, a French engineer, to devise a method which he patented in 1818 to tunnel under the Thames River in England, the first of its kind ever built under a muddy riverbed, although its mode of boring has not been satisfactorily explained. His technique, called the tunneling shield, made use of his observations while working on a shipyard on how the shell with fine ridges were used by the Teredo to drill through the wood while protecting itself from being crushed. The Teredo also secretes a calcium-rich framework that coated the inside surface of the tunnel, keeping it stable and crush-proof. The Teredo is supposed to have been originally a native of tropical or semi-tropical seas, though now it is found in high latitudes as they continue to eat their way around the world. One article states, it does not appear to have been known to the Greeks or Romans, or at least its ravages in ancient times could not have been very great, else the unsheathed hulls of Greek and Roman vessels would have been perforated. This contradicts other articles. Scienceblog.com says, the Greeks and the Phoenicians certainly knew about them since 3000 BC, lathering the hulls of their ships with wax and tar to keep them away. The Romans used combinations of lead, tar and pitch to cover their boat. The shipworm lives in waters with oceanic salinity. It is rare in the brackish Baltic Sea, where wooden shipwrecks are preserved for much longer than in the oceans. The range of various species has changed over time based on human activity. Many waters in developed countries that had been plagued by shipworms were cleared of them by pollution from the Industrial Revolution and the modern era, but as environmental regulation led to cleaner waters, shipworms have returned. Climate change has also changed the range of species. Some once found only in warmer and more salty waters, like the Caribbean, have established habitats in the Mediterranean. Wrecks that are found in sea areas with these conditions are therefore usually left in peace. At the bottom of the Baltic Sea in the Gulf of Bothnia and the Gulf of Finland, there is a low salt content, and so the wrecks found there are often incredibly well preserved. Shipworm can survive for periods of up to 6 weeks without oxygen, by not eating and living on stored glucose in the body. This allows it to survive within the wood of a ship, visiting waters that would normally not provide good survival conditions for the shipworm. Several species habit the eastern coast of the United States. Since some of the earliest recorded references to the creatures appeared in texts from ancient Greece, the clams have hitched rides in the hulls of wooden boats and later in ballast water, settling in ports and harbours around the globe and devastating wooden infrastructure as they went. In fact, some species have become so ubiquitous, they're cryptogenic, meaning it's impossible to tell where they originated. This contradicts other articles which state that the origins are known. The shipworm has been transported by ship around the world for so many hundreds of years that the original site of its propagation is no longer known. Some believe it originally came from Europe, but there is also a theory that it originated in Southeast Asia. Nowadays, the shipworm is widespread in both tropical and temperate waters around the world. The damage done to submerged timbers around the world by the Teredo is enormous. Honeycombing the logs of wharves, piers, dikes, bulwarks, piles, injuring fish pounds and traps as well as lobster pots. Weakening the wooden hulls of ships to the point that they break apart in the open sea without warning, and other submerged wooden structures. In modern times, we have yet to escape the wrath of the Teredo. Shipworm is perhaps the worst invasive species of all time and is responsible for enormous destruction. In the 1800s, wooden ships could be eaten to pieces in as short a time as 8 years, and the shipworm was a serious limiting factor for shipping. Many different methods were used to defend against the attacks, and one of the most common was to dress the hull with copper plates on the outside. The ships of Christopher Columbus were among the first to use this protection. Nowadays, with steel ships and concrete wharfs, the problem is less, but still present. The first historically documented use of copper sheathing was experiments held by the British Royal Navy with HMS Alarm, which was coppered in 1761 and thoroughly inspected after a 2-year cruise. In a letter from the Navy Board to the Admiralty dated 31st of August 1763, it is written that so long as copper plates can be kept upon the bottom, the planks will be thereby entirely secured from the effects of the worm. And here we have another discrepancy. When did they start using copper sheathing on ships' hulls? Was it during Columbus time, 1451 to 1506? Or was it from the British Royal Navy time in 1761? Right? There's 200 years difference there. In 1731, the ravages of shipworm threatened to break down the dikes and put large parts of the Netherlands underwater in what was perhaps one of the most devastating attacks. A commission called the Shipworms a terrible plague, which led to the wooden dikes being replaced with dikes of stone along the entire North Sea coast. A portion of the pier at Yarmouth was so honeycombed with perforations that it might easily be crushed between the hands as though it were paper. The partition between the various tubes being in many places as thin as parchment. A piece broken off this pier and measuring about 7 by 11 inches weighed less than 4 ounces, including the shelly lining of the tubes. In the space of 40 days, a piece of deal was fairly riddled by these borers. This might just be a case of misinformation, but the article from wikisource.org that I took the last part from is talking about the devastation in Holland due to the shipworm, and they reference Yarmouth in the middle of the paragraph. Now, I can't find a Yarmouth in Holland, and it would have to be on the coastline. There is, however, a Great Yarmouth on the UK eastern coastline, which is actually a direct route by ferry from the UK to the Netherlands. Here is a unique 16-inch traditional Benedetto archtop guitar, made from Teredo-infested Alaskan Sitka spruce, which were used as log floats back in the 1950s and 60s. This is the most expensive archtop guitar, with the hefty price of $52,000 US. By the way, fun fact, the most expensive guitar ever was Kurt Cobain's Unplugged, left-handed acoustic electric, which sold for $6.01 million at auction. An unknown number of wharves, piers, jetties, docks, pilings, and other wooden structures started collapsing in San Francisco Bay between 1919 and 1921, resulting in almost $20 billion worth of damage in today's money, all because of Teredo. When the shipworm was introduced to the western coast of the United States by visiting sailing ships in 1913. On February the 6th, 1921, the San Francisco Chronicle noted, seemingly with grudging admiration, the worms' ability to fill 100 square feet of wood with more than 100,000 tenants. That's 1,000 individuals per square foot. These worms, some of which are 2 to 3 feet in length, are so active in their work that it's possible to hear the rasping of their tools on the wood by placing the ear against the exposed top of the pile. On March 2nd, 1920, 1,000 feet of wharf came crashing down into Northern California's Carquinez Strait, just northeast of San Francisco Bay. The problem wasn't shoddy construction. The problem was the Teredo shipworm. As recently as 1946, damage by shipworm on ships and port facilities in the United States alone was estimated at $55 million a year. For 2 years, the devastation ensued at the rate of one major wharf, pier, or ferry slip every 2 weeks. Just think about that. Given that cost, maybe it's poetic that shipworms likely arrived with gold rush prospectors. In 1849 alone, the year gold was discovered at Sutter's Mill, 650 ships arrived in the bay, and many were just abandoned there. In the space of a decade, Nature reported many wharves were derelict and tottering from their attacks. In Seattle's Puget Sound, the US Army Corps of Engineers authorized the dredging of the Snohomish River and the construction of a new jetty in the ocean near its mouth in 1890 to concentrate the river's flow into a protective pocket. Other ports like New York Harbor, the Hudson River, and Los Angeles Harbor, which had been protected by industrial pollution, experienced devastating resurgences of shipworms and wood-boring isopods known rather charmingly as gribbles, after clean-up efforts like those required by the United States 1972 Clean Water Act. Because many shipworms, including Bankia cetacea, the species native to the continent's west coast, require high salinity to thrive and breed, estuaries and river mouths can shield wooden ships and marine structures from damage. Natural freshwater ports were quickly developed, while some saltwater ports were altered to increase freshwater circulation. The mouth of the Hudson River of New Jersey and New York was once considered a dead waterway, devoid of fish life because of the overwhelming industrial pollution since the 1930s. Ship captains used to sail their boats through New York Harbor just to kill off shipworms and barnacles. That's how polluted it was. But due to the Federal Clean Water Act, by the 1990s, the fish had returned, and so did the Teredo, with a vengeance. This period also saw the voluntary ban by the lumber industry on the use of creosote and CCA, chromated copper arsenate, to prevent further leaching of the toxic chromium and arsenic to the environment. Because of this, piers and piling along the Hudson River that no longer used preservatives started collapsing, hallowed through by Teredo worms. In 2009, Teredo caused several minor collapses along the Hudson River waterfront in Hoboken, New Jersey, due to damage to underwater pilings. New York had grown during the second half of the 19th century to become one of the world's premier port cities, handling 6 million tons of international goods in 1900. By 8 years later, 23 piers lined the waterfront. One of them, Central Wharf, stretched 2,000 feet into the bay as if beckoning the mollusks to feed. The journal Nature estimated the damages caused by shipworms in the bay at $25 million between the years of 1917 and 1921. Conservatively, that's more than $300 million today. By the end of 1921, the bulk of structures with untreated piles had been destroyed, reported Nature, sometimes carrying buildings with them. Andrew N. Cohen, an environmental scientist with the Center for Research on Aquatic Bioinvasions, writes that the casualties included loaded freight cars from Union's railroad dock, the municipal wharf, and customs house for the town of Benicia. 3 grain warehouses, 1 highway, and 2 railroad bridges, and 12 ferry terminals. Even now, in 2022, marine borers have come roaring back into New York Harbor, threatening almost anything in the water made of wood. They relentlessly attack the timber pilings that hold up the pristine lawns, basketball and handball courts, soccer and lacrosse fields, and roller skating rink, and threaten the future of an 85-acre park that has become a showcase for New York's waterfront redevelopment. The improved water quality has been a welcome back sign for the marine borers. Marine borers took out a heavily used Brooklyn footbridge over Sheepshead Bay in 2015, requiring the city to close it for several months to repair a hole-ridden foundation. The borers have also weakened timber pilings under the Carroll Street Bridge over the Gowanus Canal in Brooklyn and under the FDR Drive in Manhattan. Along the New Jersey waterfront, their handiwork led most notably to the partial collapse of a pier at Frank Sinatra Park in Hoboken. It looked like something took a big bite out of it, recalled Leo Pellegrini, the city's Director of Health and Human Services. The pier has since been rebuilt with pest-proof concrete and steel pilings. The marine borers have also become a nuisance for the Port Authority of New York and New Jersey. Last year, the authority spent $6.2 million to encase 294 timber pilings in concrete, or about $21,000 per piling, under 3 Brooklyn piers. It is currently assessing the condition of the timber pilings at all its piers and wharves in the region. Now, Brooklyn Bridge Park is taking a stand to ward off the pests. It is undertaking a 4-year, $114 million project to coat 11,000 timber pilings under 4 of its piers with epoxy as a way to prevent any further damage. It's a massive undertaking, said Eric Landau, the president of the Brooklyn Bridge Park Corporation, which operates the park. What we're ensuring by doing it is that this park is here for generations to come. For divers who love diving on wrecks, the shipworm is an enemy which eats up cherished wooden shipwrecks. Despite the fact that shipworm has traditionally not thrived in the Baltic Sea since 2000, more and more discoveries have been made of infested timber in the southern parts of the sea. Since earlier times, it's been known that the shipworm has multiplied every 2 to 3 years along the German Baltic Sea coast. But now it has been reported that over 100 wooden wrecks are infected by shipworm from the inlet of the Baltic Sea and east to the island of Rügen. It is not known what has caused the shipworm to have established itself in this area, and both changes in salinity and the shipworm's adaptability have been mentioned as possible factors. It is also speculated that it may not actually be the salinity that is the determining factor for shipworm propagation, but rather it is temperature. In Finnmark, which is located in Arctic waters, the shipworm is rare or not present at all. German scientists are now investigating whether a combination of warmer summers with higher sea temperatures, milder winters, and a greater supply of nutrients from agricultural runoff may have led to the shipworm being able to establish itself in the southern area of the Baltic Sea. If the German researchers are right in their assumptions, this means that only a slight increase in temperature, and hence the salinity due to greater evaporation, will give the shipworm better opportunities to survive. The environment in the Baltic Sea can thus be severely threatened with global warming, and many marine archaeologists and divers fear that the shipworm in time will invade the whole of the Baltic Sea and destroy the many amazing treasures found there. When the magnitude 9 earthquake struck off the coast of Japan in 2011, it measurably shifted the country's main island eastward, tweaked the tilt of Earth's axis, and killed nearly 20,000 people with the towering wave that followed. The tragedy also sucked an enormous amount of buoyant stuff out to sea: fishing boats, docks, plastic flotsam, offering scientists an unprecedented look at how species raft to new environments on anthropogenic debris, a mechanism that is increasingly influencing ecosystems. With the help of volunteers, government officials, and funders, more than 50 taxonomists have identified about 300 different species that survived a journey of thousands of kilometers across the ocean to Hawaii, California, Oregon, Washington, British Columbia, and Alaska. Among them is the little-known shipworm. Greek soldiers tarred their fleet with pitch before setting off for Troy to protect themselves from such hazards. The Viking saga of Eric the Red, dating to the 13th century, holds shipworms responsible for sinking and drowning the poor explorer Bjarni Grimolfsson, thought to be the first European to see the North American mainland. They got to Columbus too. Two of his ships in 1503, his first voyage to the Caribbean Sea in 1492, exposed his ships to the world's most Teredo-infested waters, likely due to the higher salinity and higher seawater temperatures of the Caribbean. The ships that arrived later brought back Teredo navalis to Europe, where they can be found even as far away as the North Sea, having adapted to the cold environment. Columbus was forced by these small clams to land on Jamaica. He and his crew were marooned for a year before being rescued. Some believe that the ship that inspired Moby Dick was weakened by shipworms before a whale took it down. Same with the Spanish Armada, which may have brought the stowaways with it from warmer waters. Dan Distel, a shipworm biologist at Northeastern University's Ocean Genome Legacy Center, shared what an old professor told him with The New Yorker. If it wasn't for shipworms, we'd be speaking Spanish today. And there are claims that shipworm appetites might have been a factor in the English defeat of the Spanish Armada in 1588. The Spanish had remained docked in marine waters of Portugal for several months before engaging the English, providing plenty of time for infiltration of ships' timbers by the Teredo that would have weakened and slowed the vessels. In 1579, Sir Francis Drake spent over a month on the Californian coast repairing the Golden Hind, which had been damaged by shipworms. This is a section from another article about how a Florida homeowner tackled the problem with shipworms. My point here is, if these treacherous clams are so troublesome, and clearly have been for thousands of years, how come we know very little about them? Seriously, with this scale of destruction, you'd think this would be pretty high up on the priority list because it's costing companies so much money. I'm assuming also government departments, because they are responsible for public buildings and structures like piers. Florida homeowner Dr. John Morrow learned about the hardships of damage caused by shipworms firsthand when his recently installed wooden dock pilings were invaded by the wood-boring bivalves. Within a matter of years, the shipworm had consumed a significant portion of the wood pilings, dictating the need for replacement. Dr. Morrow had already built the dock of his dreams twice. The dock in St. Petersburg, Florida, succumbed once to shipworm damage and once to storms. Before rebuilding a third time, the surgeon decided he would handle things differently this time. Dr. Morrow explored possible preventative measures. As he learned, his options were limited. Metal sheathing surrounded each piling is always costly and can prove ineffectual due to corrosion. Cement casings crack under the pressure, and plastic and fiberglass coatings only cover up the problem. With plastic dip, he reasoned, all it takes is one boat rubbing up against it, and the seal would be rendered useless. Pumping the piling full of chemicals can temporarily slow the worm infestation, but Morrow was looking for a permanent solution. Building another wooden dock would be tantamount to throwing good money after bad. So he did some research and came across fiberglass pilings. He reached out to a company that provided this, and they all lived happily ever after, except for the shipworms. In a nutshell, he found a solution, but what a friggin' drama. Pterodophyra dominicensis, a shipworm species discovered in Dominica and previously thought to live exclusively in the Gulf of Mexico and the Caribbean Sea, are rapidly infesting the areas around the Mediterranean, suggesting they were well established there too. Combined with documented increases in local sea temperature and salinity, this doesn't bode well for Mediterranean cities such as Venice in Italy, which still has loads of wooden pilings and other structures in the water, and plenty of problems with the resident shipworm and gribble species. For all the damage shipworms have caused through the ages, you'd think they would know more about them. And of course, last but by no means least, the hundreds, possibly thousands of ships throughout the years that have been sunk at sea. One paper even claims that shipworms sank more ships than pirates. This, says mostly retired marine biologist Kevin Eckelbarger, who plans to write a book on shipworm history, is an animal that Captain Cook feared as much as the Hawaiians, who probably killed him. The Dutch, for their part, soon girded their dikes with expensive imported stone instead of wood. but not before certain religious institutions declared official thanks, fasting and prayer days in hopes of warding off this new divine plague, and not before Celius catalogued some 500 to 600 methods of preventing shipworm invasion, according to the Nautical magazine for 1878, some of which are more amusing than practicable, including for ships an inner layer of calf skins, cow hair, pounded glass, ashes, glue, chalk, moss or charcoal. In the United States, hopeful inventors had submitted 1,000 shipworm deterrents to the US Patent Office by the end of the 1800s. Canadian logging companies detonated dynamite in the water to create a pressure wave that killed shipworms inside floating logs. Chemical concoctions came into widespread use, often polluting waterways. Mariners scoured the world for naturally repellent wood, contributing to deforestation, particularly in the tropics. Few of these defensive tactics did much more than postpone invasion, so people also went on the geographic offensive, according to Nelson, making the shipworm their unwitting co-author as they reshaped North American coastlines. So, I think I got my point across. Okay, it's a long video just because of all those things. But my point being that one really would think that after so much worldwide damage for this long and the cost, that we would have found a solution or even understand these critters a little more. Today, we still don't know how they devour so much woody plant material as fast as they do. The ancient Greeks wrote about them. Christopher Columbus lost his fleet due to what he called the havoc which the worm had wrought. And today, shipworms cause billions of dollars of damage a year, and yet still they remain a curiosity. Compared to wood-eating animals on land like termites, shipworms have been largely neglected by scientists. As a result, we know very little about how these keystone marine organisms digest woody plant material. Really? We know very little about an organism that has cost us so much money in industry for thousands of years because we ignored it? Seriously? New research from the University of Massachusetts Amherst, published in Frontiers in Microbiology, reveals, however, that we still don't know the most basic thing about them: how they eat. It's unbelievable, says Reuben Shipway, adjunct assistant professor in microbiology at UMass Amherst, research fellow at the Centre for Enzyme Innovation at the University of Portsmouth in England, and one of the paper's authors. Shipway says, we still don't know how they do what they do. Part of the problem is that the nutritious part of wood, cellulose, is encased in a thick and extremely difficult to digest layer of lignin. Imagine a really thick, unbreakable eggshell, says senior author and UMass professor of microbiology, Barry Goodell. Certain fungi possess enzymes capable of digesting the lignin, and it has long been thought that symbiotic bacteria lived in shipworms' gills also had the enzymes. We thought that the bacteria were doing the work, says Goodell, but we now know they are not. At least they know something, even if it's something they don't know, right? Researchers are still trying to figure out what within the shipworm could be responsible for breaking down the lignin. Meanwhile, river flows are expected to decline in some places as droughts and dry, warm weather become more frequent and sea level is expected to rise, all of which could increase the penetration of salt water into river mouths and endanger wooden infrastructure that has remained protected by freshwater inputs. Hudson River Park has spent hundreds of millions of dollars since 2000, demolishing 14 older piers sitting on deteriorating timber pilings, and has rebuilt them with concrete decks and pilings, according to Madeline Wills, the President and Chief Executive Officer of the Hudson River Park Trust, which operates the park. The most recent project is Pier 55, a new park with a performing arts venue that is being built largely with money from the entertainment mogul Barry Diller. The city's Economic Development Corporation has repaired timber pilings at the Manhattan cruise ship terminal on the Hudson River, the Battery Maritime Building in Lower Manhattan, where ferries depart for Governor's Island, and at Pier 36 on the Lower East Side, which has a garage for city sanitation trucks. The city's Parks Department is also reinforcing or rebuilding pilings under an esplanade along the East River, and at several marinas in Queens and the Bronx. Brooklyn Bridge Park, which opened in 2010, sits atop 4 former industrial piers, held up by a total of 13,000 timber pilings. A 5th pier is built on landfill. It has already spent about $50 million to reinforce or encase 1,500 of those pilings in concrete. In total, the park expects to spend about $300 million on work on the pilings, or about 3/4 of the original $400 million cost to build the park. So you'd think all that was bad enough, right? And one might even think that this would be the end of the video. Well, say hello to the rock-eating shipworm. Needless to say, scientists are baffled. This seems to be a consistent state for scientists these days: bafflement. An international research team led by Northeastern University marine biologists have discovered a new genus and species of shipworm burrowing into the bedrock of the Abatan River on the Philippine island of Bohol. In contrast to the wood-eating variation, this newly discovered shipworm, named Lithoredo abatanica, lacks adaptations associated with wood boring and wood digestion. The Lithoredo is not a wood borer and lacks the anatomical and morphological specializations typically associated with wood boring and wood digestion in other species, said Dr. Ruben Shipway of Northeastern University. It burrows into and ingests limestone, which accumulates in the guts of the animals and is expelled from the siphons as fine-grained particles. So, crudely put, they eat rock and shit sand. This strategy of burrowing into rock by ingestion is, to our knowledge, unique among the animal kingdom. The specimens of Lithoredo were collected from deposits of soft limestone in the Abatan River as part of a Philippine mollusk symbiont project expedition. The shipworms had entirely reshaped the riverbed ecosystem, the scientists said. The rocks at the bottom of the river were covered in holes, many with tiny shipworm siphons protruding into the water. Any burrows the shipworms had abandoned were now home to small fish and crustaceans. While it's clearly a shipworm, the Lithoredo's suite of peculiar adaptations as well as its diet, make it highly unlikely to have evolved from the wood-eating branch of the family, say the researchers. Instead, it suggests a very early divergence into limestone-loving ways. Finding the rock-eating shipworm raises a broader question. Because the calcareous burrow linings of shipworms often survive in the fossil record long after the wood around them is gone, these tube-like structures have been used by researchers as a proxy for the presence of woody material in an ancient environment. The Teredo throws that out the window, however. The authors point out that scientists can no longer assume the calcareous tubes were made by wood eaters.
This particular species is found only in a stretch of this river in the Philippines that runs about 3 to 5 kilometers. That's it, the only place in the world.
You can see there's a big animal just in here right now. This is really cool. Piece of stone has just split. You can see it's living inside this big piece of stone.
This one is exciting because it's a clam, a bivalve. It looks like a worm and it burrows in stone. But this one's unusual because it's not only burrowing in the stone, it actually eats the stone. We look inside the digestive system of the animal, we find the same stone in the digestive system that they're burrowing in, and they're sort of excreting like sand.
So I've got the bivalve shell just up this end, and then down this end we've got the siphons, so it breathes and excretes through these siphons. And then these hard calcareous structures either side of the siphons are called pallets. Those are structures that are unique to the family, and what they essentially do is they close off the burrow that the animal is living in.
What's most remarkable about this is what we don't know, I think. Rock has no nutrients, right? There's nothing much in there that this animal could live on. So that tells us it's doing something else. And what that something else is should be very interesting.
What you're looking at is a giant shipworm, a scientific legend that can grow to over 5 feet long. According to Wiki, it's the size of a baseball bat, so somebody needs to tell them that giants do not play baseball. Say hello to the Kuphas polythamia. Discovered recently? Discovered in the mud of a shallow lagoon in the Philippines, a living creature of the species that has never been described before, even though its existence has been known for more than 200 years, thanks to fossils of the baseball bat-sized tubes that encase the creature. Although people have known they exist, they didn't know the simplest things about them, said Dan Distel of Northeastern University's Marine Science Center. It was a very mysterious organism. Unlike the Teredo shipworm, this super elongated bivalve is a rare creature that spends its life inside an elephant tusk-like hard shell made of calcium carbonate. It has a protective cap over its head, which it reabsorbs to burrow into the mud for food. The case of the shipworm is not just the home of the black slimy worm. Instead, it acts as the primary source of nourishment in a non-traditional way. The Kuphas sifts mud and sediment with its gills. As we know, most shipworms are relatively smaller and feed on rotten wood. Wait, I thought they didn't like old wood. This shipworm instead relies on a beneficial symbiotic bacteria living in its gills. The bacteria uses the hydrogen sulfide for energy to produce organic compounds that in turn feed the shipworms, similar to the process of photosynthesis used by green plants to convert the carbon dioxide in the air into simple carbon compounds. Scientists found that the Kufus cooperates with different bacteria than other shipworms, which could be the reason why it evolved from consuming rotten wood to living on hydrogen sulfide in the mud. The internal organs of the shipworm have shrunk from lack of use over the course of its evolution. It is, as biologists note, really weird. Such biologists have long known what made these tusk-like shells, but could never manage to get their hands on a live animal. Until 2010, that is, when a scientist watching Philippine TV happened to catch a documentary about the men who dive for these animals and was finally able to track them down. Where in the Philippines exactly will remain a secret. The shells can fetch $200, so in the interest of preserving the species, marine biologist Daniel Distel and other scientists are withholding the location. It's sort of the unicorn of mollusks, marine microbiologist Margot Haygood from the University of Utah said. It's quite heavy. It's like picking up a tree branch or something even heavier. Like a baseball bat, maybe? Despite being known as a shipworm, a nod to its relatives' diet of submerged wood, the animal is actually a type of clam. It has a modified version of two clamshells at its head, while the body stretches out behind. Its body has been stretched out through evolution so that it no longer fits between the two shells, said Distel. So why on earth would the giant shipworm grow so much bigger? That was a mystery decades in the making, and one that scientists can finally answer with their specimen in hand. Your typical shipworm gnaws through wood but can't digest the stuff on its own. So its gills hold special bacteria, which produce enzymes that then move into the gut to break down the wood's cellulose into sugars for easy digestion. But that doesn't really explain why they became giant, because they're suggesting here that they know how the other shipworm breaks down the wood, but they don't. This doesn't even make sense. Maybe I'm missing something. I'll leave the link below if anyone is interested. Go there, take a look, read it, and let me know. Here we go. The giant shipworm grows so giant then because its environment, like the deep sea vents, is at all times loaded with that pungent hydrogen sulfide, a food that other critters would never recognize as food. Okay, well that's cleared up. How, though, could the giant shipworm so radically depart from its wood-eating cousins? A clue could be the giant mussels that call deep-sea vents home. In 2000, scientists discovered that a tiny variety of mussel, no bigger than a sesame seed, lives on the hydrogen sulfide that rotting wood produces, breaking down the compound with the help of symbiont bacteria. Long ago, a mussel like this may have sunk down to the hydrothermal vents to find a bounty of hydrogen sulfide, growing enormous in the process. Maybe the giant shipworm evolved in much the same manner. If an ancient shipworm acquired sulfur oxidizing symbionts, then they would have an environment that contained both their typical diet of wood and hydrogen sulfide, says Distel. So it acted as an evolutionary stepping stone, allowing them to make that transition from eating wood to living on hydrogen sulfide, and so a massive mollusk mystery suddenly becomes clear. Well, I'm glad something's clear. Divers collected tubes found sticking upwards around 10 feet below the surface. That tube is anywhere from maybe 75% to 80% buried in the mud, says Distel. About half a dozen were shipped to the laboratory where the team tentatively opened one. It was really quite amazing, said Distel. The appearance of the shipworm when it slid out of the tube came as a surprise to the researchers. That colour of the animal is sort of shocking. Most bivalves are greyish, tan, pink, brown, light beige colours. This thing just has this gunmetal black colour. It is much beefier, more muscular than any other bivalve I had ever seen. But it isn't just its discovery that stunned researchers. The giant shipworm is also surprising for its mode of survival. Gigantism is usually an indication of ample nutrients. Other shipworms feed on submerged wood with the aid of wood-degrading bacteria that live in their gills. But the newly discovered specimen had only a tiny digestive system, while the fact that the creature was enclosed in a tube suggested it was not eating mud. It's only a hypothesis at the moment, but the team thinks the giant shipworm might once have consumed wood like its cousins, before evolving to live off sulfur compounds in the gas. The giant teredo of Sumatra, Indonesia, attains the length of 6 feet and a diameter of 3 inches. This animal, however, differs from other shipworms in that it does not penetrate timber but only burrows into the hardened mud of the seabed. So there are loads of discrepancies and contradictions, depending on which article you read. The first contradiction is on how the shipworm digests the wood. Some articles claim to have the answer, while others say it's still a mystery. So this discrepancy, maybe even all of them, is what I consider a typical Mandela edit. It could also be that the articles just have incorrect information. But even if they do know how the shipworm functions, it took them thousands of years to figure out, right? All articles agree that it has long been a subject of controversy among naturalists how the shipworm and other mollusks of the same family bore their way into the timbers which they penetrate. The second contradiction is on how they burrow. The third contradiction is on how long we've known about these clams. And again, I stress it could be misinformation, or maybe the articles have just not been updated. But that still does not take away the fact that all articles agree that we have known about these for at least 2,000 years. Yet we know very little about them, or at the very least, we are only now beginning to understand them. Why has it taken them so long? Considering the damage that they've done and the cost of that damage, right? I find it amazing that this wasn't put on priority. The fourth contradiction is the origin of these shipworms. Again, some say they are native to the Caribbean Sea, others say their origin cannot be specified. The fifth contradiction is the first usage of copper-plated hulls. Okay, was it Columbus or was it the Royal Navy? The sixth contradiction is how they do or don't like old wood. Fun fact, no, strike that. Fun yucky fact, as far as I'm concerned. My breakfast is waiting for me and has been this whole time, and I'm bloody hungry. Teredo's only known predators are the people of the Philippines, who prepare these clams for a local delicacy. In the Philippines, the shipworm is called tamilok and is eaten as a delicacy. It's prepared as kinilaw, that is raw, cleaned, but marinated with vinegar or lime juice, chopped chili peppers, and onions, a process very similar to ceviche. The taste of the flesh has been compared to a wide variety of foods, from milk to oysters. Similarly, the delicacy is harvested, sold, and eaten from those taken by local natives in the mangrove forests of West Papua, Indonesia, and the central coastal peninsular regions of Thailand near Koh Phrah Thong. So basically, scientists have no idea how these worms work. They have pretty much existed for at least 2,000 years that we know of, yet we know very little about them, and we can't stop them from destroying our wood creations. Harbour and port managers who still have wooden pilings in the water would be well advised to recognise that the age of shipworms is rising again. Or to be more precise, that it never ended at all. Maybe it just never began, because this is a Mandela effect. Let me know what you think. Thanks for watching, stay healthy, stay safe, and I'll see you on my next video.